So just to recap, from there to there, I said it's a stroke height, sometimes referred as a lift or fall in millimeters, that distance. So the horizontal one, I said you must always measure 120 millimeters. After measuring 120, you divide by 12. You divide by 12 to get your divisions. So for all displacement, this table remain like that one. So from there, you need to level 0, 30, 60, all these are in degrees. So now, from this table, the one on top, this is the standard for all the motion, all the three motions, all the three displacement diagram. So from there, it's going to differ depending on the displacement diagram which you are going to draw. Today we are going to draw constant velocity using this information, meaning our stroke height will be 60, therefore from up there to there it will be 60. From there your cam must rise for 180, dwell for 60, fall for 90, dwell for 30. So before it dwell, as I told you, you must divide this into 6 equal divisions. Therefore, you take your stroke height, you divide it by 6. That one is for constant velocity. For constant velocity, you take your stroke height, you divide it by 6. Therefore, you will have this table at the bottom. So having this table at the bottom, after divided by 6, now you check the performance of your cam. Your cam says it starts by rising. It rises from 180, meaning from 0, you need to count 180 degrees. When you get to 180, at the max, you put your roller, and at the minimum, you also put the roller. You draw a straight line. That's a straight line when it rises. From there, it says dwell for 60. When it dwells, it does not go up or down, constant. So it dwells for 60. We stop at 180. For the next 60, which it will be 30, 60. Every each division is 30, 30, 30. So from there to there is where it's going to dwell. It has dwell there. From there, it says fall for 90 degrees. Therefore, from where we have stopped, we need to count 90 degrees. 0, 30, 60, 90. It means it must fall up until 330. Straight line, the bottom must fall up until to the bottom. There it is. It has fallen. From there, they say dwell for the remaining 30. Now we are going to draw uniform acceleration retardation. Uniform acceleration retardation. You cannot able to draw a uniform acceleration retardation if you do not know how to draw a constant velocity. Back to mathematics. For you to calculate constant velocity, you must first calculate, you must drive okay. I was saying for you to draw for you to calculate acceleration, you need to have velocity. For you to calculate acceleration on mathematics, you need to drive velocity. Same applies here. You cannot draw acceleration if you do not know how to draw velocity. So meaning our acceleration, it must be drawn on velocity. If the question says draw constant velocity, or the motion is a constant velocity, this one you're done. But if they say draw uniform acceleration, you first draw this one, but you are not done. You still to continue on this one. Do you understand that part? Okay. Now we are no longer going to draw constant velocity. We are going to draw uniform acceleration retardation. So drawing uniform acceleration retardation, it's our motion complete. It's not complete, ne? Yes, it's not complete. It's only complete when you were drawing constant velocity. So now let us continue drawing a uniform acceleration on this one. So what do we do? We must now consider the rising. Rise. Rise happens between which angles? Rise happens between which angles? Sorry? Between 0 and 180. Ne? Which angle is in the middle between the rise? 210. Between the rise, 210 is not in the middle. Sorry? 90 is in the middle between the rise. Ne? So, if you check in the middle angle, the middle line which I have just drawn with the constant velocity, there they intersect. So that's your point. And below that we have this corner and that corner. We have two corners. So with these two corners below, you take a roller from the same corner until 0, you draw a line. You also draw a line there. above this, you have two corners. So you must also draw a line from the end of the rise. There it is. Draw. When we are going up, I have drawn two lines, the blue one. Can you see them? Eh?
Yes.
When we go up, we have the first one and the second one. You see them all, eh? When I go up, I have the first one and the second one. So from this side, when I go down, I have this as the first one and this as the second one. Because if I go up, when I'm here, I go up. Which one will be my first one? Because the starting point is, can you see? It means I'm going away from the drawing, so I need to go down. So when I go down, this line is my first one, this one is my second one. When I go to the left, 30 is my first division, 60 is my second division, right? And now I'm starting from the start of the rise. When I start from the end of the rise, I must go to that direction. Which division is my first one? Which angle is my first division? 150. And which one is my second? 120. So okay, where the first division intersect with the first line, that is my mark. It's my point. Meaning, if you check, here is my first division with my first line, there is my point. My second line and my second division, there is the point. When I'm from this side, my first division and my first line, there's the point. Second division and second line, that is another point. So from there, you take a flexi curve or French curve or a flexi roller, you join all these points. They will give you an S shape. If you are using a flexi curve, make sure that your flexi curve touches this point, this point, this point, and that point. Then you draw the curve. After drawing that curve, you again touch this point, this point, this point, this point, you close the curve. So now we need to focus between the fall. The fall happened between which angles? 240 and 330. Between 240 and 330, which angle is in the middle? 0 is in the middle. 270 is not in the middle. 280 is not in the middle. 285. 285 is in the middle. And if you check here, we do not have a division of 285, ne? So we must put that division of 285. There it is, our 285. Ish. Yes, that is our division 285. So what happens? Once you divide one angle within the rise or within the fall, you must divide them all. So for the fact that we have divided this one, even here is within the fall, we must also divide. Even here, we must also divide. Is there a need to divide here?
No.
There's no need to divide that because that one is outside the fall. Ne? Yes, even here, there's no need to divide this here because this one is not within the fall. This one is within the dwell here. Yes. So from there, you said this line is in the middle. So let me make it black. Same applies. From the top, from the start of fall, I put the roller. From the start of fall, I put the roller. There it is. To the corners, 2 corners as on the other side. Even from the end of the fall to the corners. There it is. When going up, this line is the first one, this one is the second one. When going down, this is the first one, this is the second one. Going down here, going up there. When going this side, this one is the first division, this is the second division. So the first division with the first line, second division with the second line, first division with the first line, second division with the second line, as you did this side when it was rising. So from there you join. So that is your motion. Remember, I said all motion you start like this, ne? The horizontal line, always 120 millimeters. To get this division, you divide it by 12, meaning from here to there is 10, 10, 10, 10, 10, 10. Then you level 0 up until 360. The distance from there to there, it's a stroke height. So now, on this top one, we are going to draw simple harmonic motion. Using the same information, we are going to draw a simple harmonic motion. So now, quickly draw this table so that we can be able to draw a simple harmonic motion. For simple harmonic, you take a stroke height. Take a stroke height and divide it by 2. You take a stroke height, you divide it by 2. Then after dividing by 2, you take a stroke height, you divide it by 2. After dividing by 2, this one becomes your radius. From the center, then you draw a semicircle like that. Then you extend that line. Also this line, you must extend it up until that point. From there, you take a protractor, you measure 30, 30, 30, 30. It's 30, 60, 90, 120. You measure. Or you take your compass, you put it there, you mark, you also mark, you put from the start, you mark, you also put up there, you mark. Then you join your marks where you have marked. From there, from your mark, you draw a horizontal line. So from there, it rises up until 180, according to the information. From 0, you said corner, 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 corner. If you check, it reaches 180. Then you take a flexi curve, you draw. You will get an S shape. You join all these points. From there, here it dwell. So, from it falls for 90. It means when it reaches 330, it must be at the bottom there. Corner, corner, corner does not reach the bottom. It reaches the center. For it to reach the bottom, you must divide all the angles. So, you need to divide all the angles this side so that it can reach the bottom when it gets to 330. You divide all the angle within the fall, because when you go corner to corner, corner to corner, it does not get to the bottom. So now, after I have divided, I try again corner, 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 corner. Yes. At 330, it reached to the bottom. This must be an S shape. Then from there to there, it dwells. So this one is your simple harmonic motion. This one is an uniform acceleration retardation.